This time we count rather than measure. How many stretches of side-by-side numbers add up exactly to a target k? The values may even be negative. Checking every possible stretch would be slow, so we use running totals and a hash map to count them all in a single pass. The insight builds on prefix sums. The sum of a stretch equals the difference of two prefix sums. So a stretch ending here adds up to k whenever the value prefix minus k has occurred as an earlier prefix. But now, because we are counting, we do not want just whether it appeared. We want how many times. So the hash map stores each prefix sum together with how many times we have reached it. For each position, we add in the stored count of prefix minus k. A hash map gives that count in order one time, so the whole scan is one quick pass. We keep a running prefix sum, a total count, and a hash map that starts with prefix 0 seen once, standing for the empty start. For each value we extend the prefix, then add in how many earlier prefixes equaled prefix minus k, since each one marks a stretch summing to k. Finally, we record that this prefix has now been seen one more time, and at the end return the count. Let's build the counting version live block by block. Set up the running prefix sum, the answer count, and a map with prefix 0 already seen once. Walk the array, extending the prefix sum by each value. Add in how many earlier prefixes equaled prefix minus k, each marking a stretch summing to k. Record this prefix one more time, then at the end return the total count. Now let's test it and hit run. There we go. 6 different stretches in this array add up to exactly 3. The full flow. Start prefix and count at 0 with the map holding prefix 0 once. For each element, extend the prefix, add the stored count of prefix minus k into the answer, then bump the map count for this prefix. When the array ends, return the count. We visit each element once and every hash map operation is order 1, so the time is order n. The space is order n because the map can hold one entry for each distinct prefix sum. 3 careful points. Because we count rather than measure, the map stores how many times each prefix occurred, not a single index. Seed it with prefix 0 at count 1, so stretches from the very start are counted, and always add the lookup into the answer before recording the current prefix. Otherwise, a 0-valued k would count a stretch against itself and overcount.